In this lesson, we're going to look at linear equations, and so to understand more about them so that we can use them. So let's look at some examples. All right, first example. Given x plus 2y equals -6, and we want to solve for y. So a lot of times we're going to have to rearrange a linear equation for a given variable, and we want to be able to do that. And so here's some practice. Okay, so solving an equation for a given variable has the same process if we were solving an equation to get an answer. Just means that some things might not combine like we would with numbers. So we want to get y by itself. We notice that the x is hanging out over there. It's a positive, so to undo that, we're going to subtract x from both sides. So here we get 0. We get 2y equals -x minus 6. Remember, like terms, those are not like terms, so we have to just keep it there. And we have 2y equals all of that. To get y by itself, we need to get rid of the 2. It's multiplied, so the other, to undo it is to divide by 2, but we have to do it to each term. And so over here, 2 divided by 2 is 1y. Remember that there's a 1 here, so that's a -1/2 times x, can be written that way as well. And then 6 divided by 2 is 3, so -3. And now y is all by itself, so there is our final answer, -1/2 x minus 3. Next example. If the ordinate equals the abscissa, so this is some vocabulary. Ordinate equals the abscissa. And they give us some more information. X includes -3, 0, 1, and 2. Which set of ordered pairs satisfies the given conditions? Ordered pairs. So we need to write ordered pairs based on this information. So the ordinate equals the abscissa. And so knowing that one of them means x and one of them means y is very key. And we know that they are the same. So we know our x coordinates are -3, 0, 1, and 2. So if we're going to write ordered pairs to satisfy this, that means we're going to have -3, -3, 0, 0, 1, 1, 2, 2. Next example. Write the following equation in general form. So we have different ways to write equations. General form is in the format of ax plus by plus c equals 0. And our equation is going to be 1/2 y minus 1/3 x minus 1 equals 0. So what we notice on the first hand is that our x's and y's need to swap places. So that's fine to do as long as we take the signs with it. So it's -1/3 x plus 1/2 y minus 1 equals 0. Although this doesn't look quite as pretty, so we do want to make sure that at least the first term, this one right here, is not a negative and not a fraction. So sometimes we have to go that far. So if I multiply the whole thing by a -3, that should get rid of it. So -3 times a -1/3, remember how you multiply fractions. So that's -3/1 times a -1/3. Multiply straight across, we get 3/3, which is 1. That's the idea. So we have 1x. But then we have to do it to the other one. So -3 times 1/2 becomes -3/2 y. And -3 times -1 is a +3 equals 0. And so this would be our final answer. Another way that they might do that is to get rid of all the fractions. So just to be clear, I'm going to back us up a little. And what we are going to do is, how would I get rid of the negative in the front, but get rid of all fractions? And so I look for my least common denominator, which would be 6. So I'm going to multiply everything by -6. So -6 times -1/3. So let's take a look at how that works. So then we have +6/3. 6 divided by 3 is 2. So we'd have 2x. -6 times 1/2. Half of 6 is 3. So we'd have -3y. And then -6 times a -1 is a +6 equals 0. And now we don't have any fractions and we are good. So it just depends on what they're really asking for and how we need to go about this. All right, next example. So they give us 2x plus 3y equals 6. And they want to know, what is the x and y intercepts? X and y intercepts. So we have to think, what does it mean to be an intercept? Well, we're going to the graph on that. And here's our x-axis and our y-axis. And so if we want to intercept, it means we cross over. And what are we crossing over? The axis. So if we're looking for an x-intercept, we're right here on the axis. And if I look, if I'm anywhere on this axis, what is y? Well, y is 0. So if I want to find an x-intercept, I'm going to abbreviate, this means that we have to set y equal to 0. Okay? So you can probably imagine how we find the y-intercept. All right, so plug 0 in for y. So we have 2x plus 3. Instead of y, we're going to put 0 equals 6. We're going to solve for x. So 2x, 3 times 0 is 0. So now we have 2x equals 6. To get rid of the 2, we divide by 2. And so we have x equals 3. So the x-intercept is at the point 3, 0. Okay? All right. Now, if we want the y-intercept, as you can see, we'd be on the y-axis, and so that means x would have to be 0. So if I want a y-intercept, this means I make x 0. All right, so let's plug that in. 2 times 0 plus 3y equals 6. 2 times 0 is 0. We get 3y equals 6. Divide both sides by 3. 6 divided by 3 is 2. And so the y-intercept is at the point 2, 0. And let me bring that back. The next example means that we are going to graph this using intercepts. So the reason that we went and wrote these as points is because now I can plot those on a graph. So we have the point, oops, I just realized a mistake. I wrote them backwards. Don't do that. Oh, I know what I did. Okay. What do I need to erase is this because I wrote x instead of y. So we have y equals 2. It's at the point 0, 2. There we go. Okay. So these are 2 points that we want to graph, and that's how we could graph this line. So if it said graph using intercepts, then I can use these 2 points, 3, 0 and 0, 2. So let's take a look. Here's our graph, x and y. And we had the points 3, 0 and 0, 2. So that means we're going to plot them on this graph. So the point 3, 0, we're going to go on x first, 3, and then nothing on the y, so we're right here. And then 0, 2, so nothing on the x, so we're going to go up to 2, positive 2 on the y. And then we play connect the dots, and that line is graphed. As always, as you're working through the lesson, if you have any questions, be sure to ask your teacher. Have a great day.